Recording. Okay, so today we're gonna cheat and we're gonna copy paste Nathan's code. That's the
That's
plan.
not cheating, right? It could as well be on his brain or whatever.
uh, so what we have to do today is to finish these two functions.
Oh, I think he finished. Dude, that was way faster.
Well, if you have your Emacs setup ongoing there, you can test it. While you
Yeah,
test, I'm
I'll
gonna continue
test.
doing this.
Yeah.
Okay, so the code is pretty much already here, so I'm gonna just copy paste. We just have to translate this to Haskell stuff. And again, thanks Nathan.
And wow, check if it's actually correct, right?
Yeah, there is
I
also that part. Um, okay, so to type an E-type abstraction, what should we do? We have a parameter in a body. So the parameter, I'm assuming, is what we are calling label. Uh, you add that to the environment in respect to the bounded type variables, which makes sense. You just update with a new env prime. Then you type check the body using that env prime, and then you pick the result and form a type for all. Yeah, that makes a lot of sense to me. I think this is correct. But this is the easiest one, right? The type application is the conversation that we're having here. So let's see if we can replicate this with do notation. So as far as I can tell, we're gonna have to do this type env that type env that. Then we're gonna have to create another thing. I don't know, new bounded. What is the name? Bounded types, which is do we have set manipulation? I think we already did some sort of.
We did something with sets, yes.
Yeah, that's what I. Oh, here. Oh, but this is mapping. Okay, map.insert. We want to do set.insert as far as I remember. Okay, so it's gonna be set.insert. Cool. Do I have the type for this? Yay, I don't. Okay.
I think if you just remove the insert and type insert and then C. Yeah.
Yeah, but this is for map. You see there?
Mm-hmm.
Okay, so how do we add stuff to sets?
Why would that be map though if you're specifically doing set.insert?
Yeah, that's also weird, right? Why Emacs is giving me something that uses an int map? Uh,
Isn't it because an int map is a set?
insert a new key value pair in the map. I think you're correct. I think it's because apparently a data.intMap.strict, which is also imported in that data.set. But that's kind of weird that to classify a map as a set, I would say.
There might be some specific.
Yeah, there is an insert function, which is cool. So let's just ignore Emacs for now.
Yeah, just trust it.
Label bounded types. Okay, as far as I can tell, this works. I'm doing. Oh, it's typer env.
For a second, I thought you were typing like I don't know Erlang again and traumatized.
No, it's fine. It's very fine. Okay, now we need to create a new env, which is he's doing in this line. Body type. Okay, so body type. It's gonna be this, which is type check that gets the env that we had. Ooh. Okay, it picks the env that we had, and it replaces the bounded types with the new bounded types. And we also need the body. Okay. Is this how you do this? I never did in this manner, so I don't know. Can you do type record wildcards with renaming?
You're asking me? I don't know, man. I
Yeah.
didn't even know the language what you're talking about.
Oh, okay. The order matters. Okay.
Okay.
And now you do type for all, I guess.
Wait, Lemus. Like usually, this pattern is also in this order, like the name of the variable, and
I never
then
saw in this order. I never saw this combination before.
no, but okay, when you are using another kind of pattern and not this extension one, is it still in this order?
Yeah, the name comes first, and then whatever. Like, let's suppose that
Oh,
you're pattern
okay.
matching the head and the tail of a list. That comes after.
Okay.
Okay,
I
so
don't know
what
if I
is a
would trust Lemus, man.
Sorry?
I don't know if I trust you, man.
Oh, okay. You can not trust me if you want. Is a set of text. This is receives a key, and that. What are you complaining here? Couldn't match type text with int. What are you talking about, friend?
The mapping, int map.
I think Emacs is going crazy. Okay, that's fine. Let's go to types and see, because the T for all now has to actually another thing, which is the T for all info, which grabs the text, which is I guess is the label, yeah, and the body type, and that should be kind of it as far as I can tell. So Emacs is still complaining about a lot of stuff.
Let's see, what is that? Wait.
Can you compile?
Label. Oh?
What is the type of body?
Can
Type.
you let's go on the first one. What is the label? Complaining.
It's because it is trying to use the insert from int
Oh.
map.
Okay.
But that doesn't make sense, and I don't know why.
Would it be an error of the LSP and just compile and then it goes away?
Yeah, but that would be very bad.
Try compiling.
Could not find module typer. Okay, so something's fundamentally wrong, I guess. Could not find module typer. What do you mean? This is a new one.
How do you organize a module, by the way? Like, for example, you make a new file. Where do you link the file?
Set key. I will try to answer you a little shortly. I just want to debug this because the error is also appearing on. So Emacs is not going crazy. Even Stack is saying, "Oh man, this should be a set.key, and you're passing to me a text."
What is a set.key?
It
Should
is
that be like
no, it is
anything?
because the set.insert stuff, like.
Yeah, but isn't it a for all blah 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 garbage there?
Isn't a for all? No.
Yeah, that should be generic, right?
Oh wait, I'm talking about this error, man. This.
Oh yes, I know. I'm saying like the set key. Like, why is it enforcing something?
No, that's what I don't know.
Oh man, it is. It's enforcing as an integer.
Yeah, but the bounded types, it is a set of values A, which is fine. And that's what. Oh, I know. Of course I know. It's because we are not using the qualified. That's why. So we need to say as set.
But what? But what was it? Oh, there are two. Oh, there's another set down there.
Yeah.
Look.
Yeah, but that's just the type constructor.
Wait, what the fuck is that line?
Yeah, I don't know. Int map strict.
Why do you need this set there? Like, is it to part specific stuff and then put to that name?
Do you mean this set?
Yeah.
It's because I'm importing only the type constructor from this.
Okay,
If I want to add more, I need to say like, "Whoa, give me also the insert function, please."
Yeah, but that begs me to question: why is line 2 useful? Yes.
Line 2, this.
No, 2 down.
2 down, this.
Yes.
Oh,
What is
this
this
is
for?
no. This was Emacs trying to help me.
Oh.
Oh, okay. So Emacs
God.
trying to help you, fucked you.
Yeah.
See, I
Very
understand
classic, I
now.
would say. A classic thing, I guess. Okay, so what is the complaining now?
Not in scope.
Not in scope. So I guess. Oh, it's not in scope. Okay, thanks.
Why don't you open everything already, man?
Because that's a bad practice. I'm trying to not do that.
You're gonna use everything on that file
No,
anyway, man. What's the problem?
sounds really bad.
Well,
You're
it
gonna
is a
use
good
Oh,
everything.
practice, but
oh, I
You're gonna
see you.
you're gonna use anything, everything on that anyway.
wait. I am exporting everything. That's it's because I need to because now the T4 is not together with the other thing. Okay. Info also needs to come here. Okay. Is it happy now? Module types does not export. Yeah, this is just Emacs need to update. Okay, so let's go Ctrl XB.
I can see why that's the case when you are importing things like set, map, and such. But for types, I don't know. It's looking quite dumb, man.
Yeah, I understand. I understand the purpose of that. It's like the same problem on .NET when you augment garbage and you lose where things are from. But
Yeah.
like just in types, I don't think it matters, man.
Okay.
And also, I saw the syntax like when you are importing the type, and then you can specify the constructors. Like I never saw that before. Man.
Yeah.
That's quite a thing.
Okay, so Emacs is still complaining that the thing is not in scope. I don't know if this is just Emacs or something. So let's try again. Okay, still have an error here.
Oh, man. My LSP is building something.
Typer.hs does not
Oh, it
export.
failed. Just because I just mentioned the thing and then it fails. Thank you. I hate you, Haskell. Why do you hate me as well?
Why does it hate? Data constructor not in scope. Perhaps you mean. Oh, I did I written it wrong? Perhaps you want to add T4L info to the import list in the import of types. I am importing that. What are you talking about? And I am exporting also. Okay, so let me think. This is exported. This is ugly. Now it's better. And I'm also importing it from here. Okay, so let's just do what you guys said. Let's import everything. Who cares? Oh, did it work? I guess so. Yeah. Okay. Okay. So is this type checking? Oh yeah. Okay. Type check. E-type abstraction is done.
Awesome.
Now the funny one. E-type application.
Oh no.
E-type application. Um, what do we have there? What are we doing? We have a to do here. Check for unbounded type variables. I think we're gonna ignore this for now because this is the part that Nathan didn't do. So we're also gonna postpone this one. Um, what should we do then? We should create something that he called function type, which is composed out of type checking, given some environment, and giving
Clarence,
expression.
If you are going to use the same names, I would be glad to do the whole project in advance, man.
No, I am now. I'm just stopping and trying to read what this means. What are we trying to do? We are trying to type check the function before the argument. Is that correct? Because if it needs to be a for all, right?
Yep.
If it's not a for all, what that means? That means because we are trying to. Can you remind me, Nathan, what is an
And
E-type
paste
application?
it. I can paste it.
Just to me to be sure that we need to have a for all.
I I have
Oh,
it on the
it's
chat.
when you're trying to apply a type because oh yeah, okay, it's because the parameter that we are expecting is a type and not an expression. And the only type that we accept for now is the T for all. Is that correct?
Yep.
Okay, makes sense. Case function type of if it's a T for all with I don't know, some info here, we're gonna do something. If it's everything else, we're gonna left saying what. Give me a good error message, Magetta.
Let me see how .NET would handle that. That would
Well,
be. Wait, I wasn't paying attention. Sorry, I was compiling the thing. So, what is the context?
We have an E-type abstraction. We check if the expression that we received is actually. We check if the type of that is a T for all, because this is the only thing that we expect. If it's anything else, this is not a function that expects a type, which means that
Okay.
this doesn't make sense, and then we're
So
gonna throw an error.
think of a generic enterprise way of saying for all.
oh no.
But yeah, that's. Now, let me teach you how I make those error messages. Like, think of an enterprise way to say for all.
um,
Like, for example, enumerable. That's an enterprise way to say like a list or whatever. So you see enumerable as an interface. Expected an expression.
uh, that's a hard error message. Nathan,
Expected
give me
and
some hope here.
I literally had the error message there.
expected and spreadable type cannot resolve.
Okay, let's see. Um,
What? Express
do
them?
a type.
Spreadable. That doesn't
What?
mean anything, but when you analyze it closely, that means spreadable. That means that you can pick many types and then you
Spread
can just
type.
spread over a huge
Abstract.
domain.
Okay,
If
so
that
this is the error
sounds like
message that
BS,
Nathan did.
that's because it is.
Cannot do a type application with a value that is not a type abstraction.
Oh, that's not enterprising, man.
And I don't think this is
Accurate?
yeah, because the error is not that. The error is that this will be the error of if this of something later on the line. But this error is the expression that you have is not the
Type
type that we
abstraction.
need.
No, wait. That's exactly what it says there, man. You are trying to
Wait,
do a
let
type
me read it again.
application.
Cannot do a type application with a value that is not a type abstraction. Okay, no, that's correct. That's correct. Okay, while Namageta is thinking about an enterprise way of saying this, we can continue. Um, um, okay, so what do we have there? We have a T for all info, and that has an identifier, and
I'm
another
so
type
proud of you,
var
man.
prime.
I'm so fucking proud.
What do you
Hmm?
mean?
Identifier.
Parse error on type. I don't know, ident type.
Okay,
Then,
I
then
remove what I said. I
I,
take
I
back.
take that back. Now we need a function that we don't currently have, which is substitution that grabs the identifier it grabs the argument, which is type prime, and the ident type. Right.
Type received could not be generalized to an abstraction. What about that error message?
Okay, can you
Wait, can
repeat?
you repeat?
Type received could not be generalized to abstraction.
Type
Generalized to
received
abstraction.
Or
be.
constrained, or actually not generalized, right? Constrained in this case.
Wait, but I'm more worried about the type received part, in the sense that that's not the error.
Well, the error is cannot do a type application. So you got a type. Okay, I get what you mean.
Like, because we are receiving a type.
Yeah, it looks misleading. Yeah.
Yeah, so yeah, I can think a little bit more about that.
Yeah, I'll think about it.
Okay, because this function will also be used to do the equality, if I'm not mistaken. Type equal also uses this. Yeah, the type equal also uses type substitution, so this function needs to be somewhere else, and it's gonna be here.
Man, everything can fit there. Like, it's everything on the typer.
No, it does not, because the the type substitution function will also be used to do the equality of this.
Oh, okay, yeah, I see.
Substitution. I don't know how to write that. That's a complicated word.
I had the same problem.
Okay, substitution seems to be correct. What this does, this picks two labels and a type. Is that it? Or am I going crazy? No.
It's
It's not.
actually a string, a type, and a type.
Yes. Okay, so it's a string, a type, and a type. Substitute.
Yeah, we need something there, man. Even something like comments, maybe, um, to tell what are those things, because
Oh yeah,
it's
that's
not
very
Damn
intuitive
involved.
it.
at all.
I found it. I found the problem. I found the problems.
Oh yeah,
I just
great.
needed to install Rosetta. That's it.
Oh, holy crap! You were not using that
I
before?
formatted my computer. I
Oh.
forgot it.
Oh,
Okay, let's remove this. Um, Wait, the return of this is a type. So, what are you complaining? Couldn't match expected type. Wait, I
don't
am.
you need like?
Wait. The return of this is a type.
Yeah, you need the right? Oh no, you have. Wait, you have pures.
Yeah. Is the
Okay, it
do the
works.
problem? No. This is correct indeed. What is complaining here also? Variable not in scope. Type a result. Could not match type with either text type. No! I'm
What?
dumb.
Like the result?
This is not a let.
Oh,
Okay, thanks.
oh.
Now we have this one. Couldn't match expected type. Type to type with actual type. Wait, what? Type substitution is a function that expects a text, a type. Oh, we are passing three things to it. Okay, so this is wrong. We have three things here. So it's a text, a type, and returns a type.
Does Haskell accept Unicode?
Never tried that before.
Like as a name of a variable? A function?
That would be really good.
That would be.
I mean, it's not like I have any ulterior motives. I'm just asking.
Well, why not? Let's try. I would be very, very surprised.
As the name of a variable, I don't think so. I think you can use it inside strings, but not as a variable name.
Yeah, parse error on input. I don't think it allows.
That
Our
code.
language will though. So
Oh yeah, we lost time on that. You better do it. You better do it.
okay, the type now just have to do type substitution and change the equality, but the type checking is done, I guess. If I'm not mistaken. You're gonna have to test this at some point, but well.
Yeah, that's really important.
You listen to that, Magetta? It's
Oh,
really
it's
important.
typing, so it's fine.
You
I,
listen
I
to
don't.
that. It's really
I saw
important.
a post on a Python guy talking about people just want types because they don't want to test, and I said,
Of course.
well, no, but I don't like testing, so
Wait, but I don't testing like in automated testing, but like even manually, we need to see if this is working.
Oh yeah.
okay.
Okay, so
Yeah,
what are the
automated
names for
testing no
this?
need, right? It's useless.
Nathan,
Hmm? What?
what are the names?
The names of what?
Substitution.
Yeah, so
Oh,
from,
you.
to, and type. What are each one of those? If I'm not mistaken, the from is the label, right?
Oh, you mean the semantics, right? Yeah.
Yeah, I think this is like
So
previous type.
okay, from is the string of the type variables that we are looking for to
Okay,
substitute.
okay, makes sense.
The to is the type that you want to replace the placeholders, right?
Mm-hmm.
And the other, it's the type that is the target of this whole substitution.
Okay.
No, that's wrong. You- no, placeholder there is the first one, like they are, right?
Oh, this is the placeholder type, right?
No. He is the type that you substitute the placeholder. The placeholder is the first one that you are calling label, right?
No, I'm confused. As far as I can tell, this is a name, and this is the type that the name has, and the label has.
No.
No, it's not. Okay. So what is? I'm
Wait,
confused. What is the from
it
then?
depends. What do you mean with has?
This name, like I don't know, for all A or something like that,
Huh?
it has this type, and I want to change every single uh, time that this appears with this. I want to replace this type with this one.
No.
That's what I understood.
So every time you see a label, you will substitute that by a placeholder inside the type target.
Can you repeat that?
Every time you see a label, or even better, a type variable with the label, you will change that to placeholder. And all of that will occur inside the type target.
Okay. Okay. So what are the better names for this? Placeholder. I don't know. Type prime. And we can just case off and call it a day.
That's why it's reminding me of Erlang.
What part? Keys
The case
off?
of.
Oh, I see.
Okay, so if you have a T unit, we're gonna just do T unit. That makes sense. Don't have anything to do in regards to
In
that.
SML, it's also case of, by the way.
So what if it's a T arrow? The T arrow has a parameter type and a return type. We have to do the same operation with both of them. That makes sense. So if you have a T arrow with a parameter and a return, what do you do?
If we
You
have the time, since we already have like this kind of stuff, we could also implement something else that is not so core or so well, like this,
yeah, we can.
like records. Right?
Well, this is kind of getting a little bit out of scope because the first plan is to have exactly the same thing as we had aside from variadic stuff. But we can
Complaining, man.
change the list later.
Are you complaining that we want to have proper types, man? What are you
I'm not
doing?
complaining. I'm complaining about
That's
the order.
complaining, Lemus.
No,
What
it's
you
not.
doing, man? You're crazy.
I'm talking about the order.
Even better, we could just add the simple types, like primitive ones. Then we can test it better, right?
I mean, I'm not
Exactly.
waiting.
That's my
I'm not
plan.
waiting. I'm not waiting 1 year so we have proper types, man.
Well, according to the plan, we have two other bullets before having proper types. So kind of like that.
Algebraic data types. Okay, being backwards compatible, we're already doing.
Yeah, we're already doing that.
CI, algebraic data types. Well, yeah, that might be some time
For
consuming.
example, C and C++. Oh,
uh, Placeholder type prime return. Okay. Um, we can make this better to read. Okay, what if it's a type variable? Not type variable. Oh my god, the same name
don't we
problem.
have a formatter there?
We probably do have. I never used it.
Type metax LSP format.
Format buffer. Possibly
Parsing
incorrect
failed.
indentation, mismatch brackets. Oh yeah, it's because this is wrong. We need to. Let's finish this, then we format.
What a terrible error message, man.
Um.
On
Okay,
F
so
sharp, even being wrong, Phantom is just formats. Formats wrongly, yes, but it
Let's not talk about Phantom, okay?
Phantoms oh man, Phantoms is a shame.
uh, um, uh, ident is equal to from. So this is equal to a placeholder. If we match in the middle of this recursive function, we match an identifier that has the same name as, then we replace it. That makes sense. Um, um, I never did this guard with a case. I'm actually not certain if this should be an error or an equal. We're gonna find out that soon, I guess. So if it's that, we're gonna return type prime.
Wait, man. When you are using guard, don't you always like need the otherwise there? So I don't think you can just use the same as we did in Okama.
You mean like that, right? Yeah, but
Yeah.
then
So you.
this is gonna be this,
Yeah,
because
it
when you're
will
doing
be.
guards, you usually do like that. But this is a case. We are combining the two things. I never did the syntax before. Uh,
Oh, I see. I see what you mean. Um,
uh, yeah, this is identifier, right? Is this correct? I'm not certain. No, it's not correct. T variable and then the name.
Your return is text there. So.
Okay. Okay, seems to be okay. I'm very surprised that this syntax exists.
Yeah,
Next.
but
It's also
yeah,
complaining
but
about the.
that will not work. That will not work, Lemos.
Why?
Well, because this pattern will match everything, like always, right?
No, but you can do that at the end. And then just do for all before.
Fair, but I think you have the same problem. Don't you have like more than? Wait, can you show the? Oh no, I have the code here, I guess. Uh,
Okay, so
also,
what if we have a T for all in which the T for
wait,
all.
wait. Can you show the comment of the code, the commented code?
The comment.
Okay, yeah, there. Variable. Oh, okay, okay. You won't have those two, right?
Yeah.
Oh, okay, okay.
Okay, so if I have a T for all info, The T4 info is composed out of a label and a type, right? No, not this type. I don't know. Give me a name again, Nathan. Oh, this one you are ignoring. Okay, let's ignore also. So what are you doing? You are saying if I have a T for all in which the identifier matches the from, then I'm gonna just return it. Is that correct, Nathan? Nathan, hello?
Yes.
Okay.
Can you hear me?
Yeah, I can hear you now. When the identifier from, or in this case the label, let's call it identifier also, because this is like the for all A. This is the A, right?
Yup.
Identifier. If this is equal to the placeholder, then what should we do? We should T for all info. Cool. If we had another case, the last case
Wait,
is
wait,
if
wait, wait.
go.
Oh, okay, yeah,
Yeah,
you're
just
okay.
eliminating. Yeah.
It's
Yeah,
because
but
I
I
thought you
think,
were doing the info to like everything, the whole for all.
and we also need to know otherwise here, I guess. So if this is not correct, it is the other case. Okay. Then this will be necessary. So this will be what? Type. I can do type prime prime, right? I can do. Okay. Then we're gonna just call it a for all. This is the one that got me confused in the last time, and I think I'm gonna be confused again. In which we call T for all info with the same identifier name, and we call a function here called substitution, in which I place the same place, put the same thing, the same type prime, but here type prime prime. Okay, so can you explain this last one for me, Nata, again, please?
Wait,
I think
yeah.
yeah.
And I had a plan which is to make, because this is when you have a literal, right? The T unit is just replacing here literal.
Yeah, maybe that's bad, Lemus.
What's bad? This,
Special cases.
and then this. Okay, go. What is bad?
Man, that can bite us like really hard in the future.
Okay, go. Explain. Why this can be bad?
No, no, the catch-all cases, literal.
Oh, we can undo this if you want.
Yeah, because like as we add more types, we need to remember to change a bunch of shit, right? That's one of the ones we should not miss it.
Yeah, that's true. Okay,
Mm-hmm.
so T integer and T rational and finally T bool. Okay.
Oh man, couldn't you? Oh no, they're the same. Never mind.
Okay, so I need to remember why do we need this thing here. So if we have an identifier which is different than the in the from placeholder, then we do the type substitution internally. Oh, this is for shadowing, I guess, right? These two, the
Yep.
separation between these two. Um, but I'm not remembering why do we need this last case though, or the first case.
Uh,
If they are equal, I replace. If they are not equal, what does that mean?
that means you gotta.
You gotta go further. That's what this other case means. You gotta go like continue the substitution.
Yeah, but you just substitute the thing inside, right?
Yeah.
So
Now, but where is the shadowing happening in this case? Because isn't the shadowing when you have the
the
choose thing?
shadowing is happening from within, like for all A, for all B, something like this, right?
Yeah.
So you're shadowing the B in that case.
You are shadowing the
Like
Uh,
you're substituting the B inside A, inside this context of A.
Wait, can you repeat that?
Like what is that case? That is like for all A, for
The
all B.
second?
Yeah, the last one, line
Okay.
yeah.
2. And then on that case, you're substituting B from the context of A. Is that right?
That's what I
I'm
got
not
also.
I'm not sure if I got it the way you said it.
Can you
Oh,
say
say in
say
your
it in
way.
your way then,
Can
Nathan?
you okay, yeah. So in B, in the body of B, you
Mm-hmm.
are substituting the things with A, right?
Yeah, that's it.
In the body of B, you are replacing with them with A.
Yeah, like whenever there is A inside B, then you're just substituting that as well.
Like as a closure, like if I write the following, so you see that the A is inside the body of the B function, the function that has B as a parameter.
Fun A, fun B, A. Okay, let me put this on this screen right here. Just a sec. I'm gonna just paste this. Okay, so we're talking about this, right? Oops. No, not this. This. Okay.
It's funny that
You,
most of the syntax works.
yeah.
Anyway, so go on, Nathan. What is the A and the B here?
So yeah, it's working like a closure, right? Since we don't have the shadowing, they will work like a closure.
Okay, so you're
So
going to the
the
body of B and you replacing these A's with this.
yeah, so the A inside B's body is the outer A, right? And even
Mm-hmm.
after I apply the outer function, the B will still have the a value that was substituted, right?
Mm-hmm.
Mm-hmm. Okay. Okay, makes sense. Last thing before. Do you have your thing running, Magetta?
Finishing compiling the
Okay.
version, but I think
Um,
you will.
okay, so because I want to pass this torch to you when you're gonna have the fun time doing testing.
Oh
Uh,
no. I hope it doesn't work here.
okay, so t unit is equal to true. Okay, this is okay. This is also okay. The for alls. Oh, you're not type checking the t variable. Oh no, you are. Okay, so we just have to pay attention to the t for all. Everything else is already been derived correctly, which is cool. So, what if you get t for all in which the identifiers are equal? Okay, so let's call this, I don't know, I
Mm-hmm.
and I. I don't know if this conflicting definitions of I. Yeah, I thought so. It doesn't have this sort of pattern matching. Like if the value is equal, like just go for it. That's sad, but
But
okay.
that's not sad, man.
That would be good, man. Imagine. We tried this in Erlang, I think.
No, man, that's not a thing.
What
Like
what was the
that's
thing?
a pattern. You cannot.
What was the thing?
We are trying when we try to match in Erlang, like, oh, if you have the value and then you want to say, like, I don't know, I, and it will pattern match when the values are equal.
Oh yeah,
We
that's
tried
true.
that.
But I guess they have that in Elixir. I'm not sure though.
Uh,
Oh, if yeah, probably they do because in Erlang you can do that. Yeah, that was very
if
cool.
is equal to this, then
I think the pattern matching was the only saving grace. I'm pretty sure of that. The only thing that could allow us to finish that project without hammering my head
else.
on the
Okay,
table.
so else we do what? we do type substitution and call that b prime. Okay, why do we need type substitution? Oh, it's because they are equal, but like for all b arrow b, it's equal to it is just the thing that we talked before, right, Nathan?
Yup.
Yeah. Okay, so it's gonna be t1 equal to type substitution ident b, so e2. Then we have to create a t variable with this name and t2.
I guess we should try doing an interpreter for a random lang later, like a fourth.
Yeah, that can be a thing. What are you complaining now? Couldn't match
Two.
t variable. T
Yeah,
variable is that type
you
variable?
want I1, I guess.
I want I1.
Wait.
I
Oh wait.
won.
Oh, wait. No, wait.
No, you're
No,
correct.
that's
I want I1. Okay.
Wait. You
wait.
are substituting
Okay.
on D2 from I2.
Okay, with the variable I want. Yeah, that's
Yeah.
that's fine.
Yeah, I guess makes sense.
I didn't.
Type. Then you just check if those are equal.
And you using Mac, like what the fuck?
Yeah, man. I was thinking, why does it? What the
I don't
heck,
want to
man?
use replace. I can use replace if I want, but I didn't want to do that.
Dude, just Control D.
Control D.
Yeah.
Isn't that
Go to
the
ident.
Yes, code.
Yeah, exactly.
Go
Isn't
to
that the VS
yes.
Code shortcut?
Yes, I made that for Emacs. It's if you're using my files, it's there.
Okay, let's try then.
That's interesting, Magid.
Control D.
He made it. I can't
Yes.
believe
That's
it.
really interesting.
He made it, man.
Just Control G. Yeah.
Seems like you like a bit of
No, I
VS
don't.
Code in your
Don't
Emacs.
even try. I don't.
Don't even try. Man. Okay. So I guess it's done now. Okay, now we need to test. Are you ready, Mageta?
Well, it's on 400. What are we gonna do after? We're gonna test.
Yeah, this is the next step.
Then it's not ready.
Wait, it's
Well,
not.
not joking. Like it is not. It's on 472 megabytes of 474 megabytes.
Yeah, okay, wait a little
Beauty.
bit. Man,
It's
but
compiling.
aren't we like okay? That to be fair to the previous Erlang version, the variadic part took a long time for us.
Yes.
So we are kind of cheating, saying that we did like in 2 days instead of 2 months.
Oh, but dude, there's no comparison. Like no, there's no comparison, man. Like even without the variadic garbage, we have a way more solid thing. Like probably a lot of the bugs that we would have there, we're not gonna have here.
Yeah, it works. At least it compiles.
Yeah, so it works.
It works. It does. It
So
compiles.
let's test with some examples, like
From the
on a
Wikipedia.
file.
From Wikipedia. Which
Yeah,
ones?
they have like booleans and tuples. Those are fun.
System F stuff.
Yeah.
There
And
tests.
there's an and up there, like Boolean stuff. Yeah, like there.
Oh, and here.
Yeah.
Okay, you can define some logic operators.
Well,
And
start with booleans first, right?
X Boolean, Y Boolean, X Boolean, Y, F. Okay, that's the neutral element, right? Wait. What? The follow definitions. Okay, it's another function up there. Okay. That's for the end. The neutral element is false.
Well, we can go like Something that I'm gonna have to remember is how to make
We can
HSpec
start
work.
simple, right? By adding another primitive type if we don't have already. I guess we do. And then we can just check the identity function first, right?
Yeah, that would be
Oh yeah,
great.
yeah,
Great.
good.
Oh, here it is. Thanks. Thanks.
He has literally a tab for silverware on his favorites.
Yeah, because I
Oh.
need to.
That's love.
I was obligated to remember to have all this documentation.
Yeah. The user guide was very helpful.
I was obligated, man. Obligated. Uh, okay, so which one first? Test typing check, type checking, or test evaluation?
Oh, type checking evaluation is surely is working.
It's a bit pointless, I guess, to testing a bunch of evaluation, man.
Evaluation, we are sure it works. Like, okay.
I'm
We
not
are
sure about.
sure it works.
I don't know about here, but it's simpler, and well, we want to compile the thing after, right? So
Mm-hmm.
it will not be our focus for a long time.
Okay, so which one is the first one that you guys want to test?
Identity. It's the easiest, I guess. Actually, no, right? Let's. Do you guys want to test System F right away, or
Oh, okay, I
that's
see.
the question?
I would go for it. Like,
Oh, okay. Let's be crazy. Okay, identity add function like yeah.
actually, that's already test everything, Magita, yes.
Or I.
Because,
Oh
no, I
yeah,
mean,
that's true. That's
testing
true.
system F already tests like everything.
Yeah, that's true. That's true.
Type. Okay. Anyway, can you guys repeat?
I conditions. I don't think conditions do right. Well, yeah. On terms
Well,
of small
yeah,
types,
yeah,
yeah.
it don't test like
Yeah, but
application or
conditions is just stupid. It's just like, oh, it's a hard coded
What
thing
about
of
testing a
the type.
literal first? Isn't that okay?
Yeah, okay, let's do that. I
Thanks for
don't know
that. Thanks for
how
that.
to write tests on this thing, so let's see.
Uh,
Dude, this is still building, man. Kill me. What the heck?
I think there's
Compiling something.
a correlation between your hatred and the thing. like,
Dude, it's still compiling
oh, this
algebraic
is how you do
garbage,
it.
man.
Okay, you
Stop.
do describe with a describe. Okay, that's cool.
Huh.
Describe.
It-
Okay, so literals. Okay, so let's start with a boolean. Uh, Oops.
This
It's
is the
bullying.
weirdest. This is the weirdest syntax to test that I've ever seen. I mean, I can kind of understand it, but man,
uh, Wait.
Tibu
No,
true, right?
it's not T boo. No, this is I'm doing it wrong. I need to call
Should be
type
the
check.
ST, right?
I
Oh
need
yeah.
to call type check, and I need to call e literal
Mm-hmm.
with something inside. That's I guess what I need to do. So let's go to the types.
Yes,
So
sir.
here literal, and then I'm gonna put
Elbow.
elbow, yeah, elbow with I don't know true.
True. Yeah.
This should type check to tbool. Okay, that sounds fine. Okay, now we're gonna add hspec to our thing, which is here.
Oh yeah. How do you add stuff to stack? Like, how do you know? How does the stack know what to execute?
Um, how does tech know how to execute? It will
Like
try. Okay, go.
like an FS Proj or on .NET, something like this. How do
It's
you
all in
specify?
here. For instance, executables. Oh, the main
Okay.
functions is inside this file, which is inside this folder.
Mm-hmm.
The options like the flags that you want to have enable are those. The dependencies
Oh,
are
okay.
this.
And then that acts like an entry point, right?
Yeah,
Everything that that thing calls.
yeah.
Okay.
And here are the tests which I'm gonna have to change.
Yeah, that's better. That's better than most shit I see.
Okay, but there
You
is
take a
a
look on June, man.
thing that I'm not gonna remember right now, but there is a thing. How to execute multiple sets of tests. 1k.
Me caveman. Me like this.
What are the chances? Go.
Very low,
I would
but
say. Uh, File name does not match module name. Okay, cool.
I mean, chances for this to work, I think they're high.
Oh, really?
Yeah.
Well,
I never
what
tried to do
exactly?
like that, man. Like we have a typer and a typer. It's gonna discover by itself which one is it's which. Is that a thing?
Oh,
Can you do that? Okay, now the
Test
main function
typer.
is wrong.
yeah, that sounds bad.
Oops.
Yes.
Uh, okay, which typer is this one? I want to know if which typer is that one?
Oh.
Modules imports from a cycle. Module
Uh,
typer
that's
imports
itself.
itself.
Yeah.
Yeah,
Yeah, so you're gonna have to change the name.
Typer, test typer, whatever, man. Just all together.
Oh, all together
No,
like
without the
this.
dot, yeah.
No, but you can make inside a folder. No, a test folder inside a test. Yeah, let's do your way. Test. And then this, this, this. Oh, now this is
Oh,
wrong.
don't you need to change the thing? Yeah. Test typer.
I think Lemons is growing a bit obsessive on like separating files and stuff, man.
Yeah.
Yeah, because this is gonna be the first Haskell project that I'm trying to do it properly this time. Okay, could
Test
not
quick
load
check.
module quick check. We're not using quick check. Who is calling for that? Oh, this guy. Data constructor not in scope.
Oh, so it's just importing, I guess, the problem.
But
Oh, did you import the
I
ST?
am importing, man. Look.
Um,
Types?
Oh, I
Don't you
yeah,
copied.
need like
Oh, you're correct. Types.
yeah.
Okay. So it's expecting. Oh, I need to provide an environment for type checking. I'm dumb.
Oh, yeah.
Um.
Empty garbage, whatever.
mm,
Oh,
In Erlang, we did a thing. We had two functions, right? We have a function
no,
called type
yeah.
check with environment and a function called type check. The function
yeah.
type check gives the type check with environment an empty environment.
Yeah, so just we don't have the hassle of
Exactly.
doing it.
And I kind of want to do that.
Oh,
I
yeah.
can't even imagine a case that we would be needing to like pass a type environment outside the typer.
Well, testing purposes, right? If you want to test, okay, I already have this preset environment. I want to type check this expression to
Oh,
try to find a
let's
bug.
go, let's go. Speed run. Add that. Go, go, go.
Typer. Okay,
You can do it.
so replace string
Can you have
type
functions with
check.
the same name and different signatures? No, right?
I don't think so.
Oh, that sucks.
Like
C sharp allows you to do that.
Okay,
overloading, right?
Yes.
is equal to type check with environment receiving empty, and then we're gonna have XPR here,
Hey, you can
XPR
just do
here.
partial application.
Oh yeah, I can, but I want to. What is complaining? Beta reduction. What is the error? Couldn't match expected type env. Oh, it's because our env in here is actually a little bit
It's a
more
type
complicated.
garbage. Yeah. Oh no, QB.
Okay, so type, type env. The first one is a set. Yeah. Okay, so it's gonna be set dot empty.
By the way, like depending on how we want to do stuff, maybe we will even need another like how can I say it? Compartment? Is that a word in English?
I don't. It depends on what you
Slot?
want to say.
Slot? That's what I say. What I say.
No, it's not a slot the one I want.
That's important.
Well, the record in
Crap.
our env will have one extra field or more, depending on how we want to implement stuff. No?
Okay.
So, so for example, let's suppose we have records, right? And they are records like we are used
Smash.
to in Haskell, right? They are nominal. So we have to declare it first and shit. So when inferring which type it is, we will get like, oh, it has this label and it has these types associated to it. But then we have to search. You have to search this in the env to see if something was declared with this shape, right? So
Okay, folks, we have
Yeah,
we
I
have
will
we
check
have a thing.
the
We
caches
have a
later.
thing.
Okay, now let's do
wow.
identity. Okay, do identity. Go. Identity. Go, Lemos. Go.
Okay.
If it
Uh,
works, you already know the Halo music, right?
By the way, if you take a look on the typer, and if you check the line that's doing the type check for this, is how can I say it? It's so much less code than the test of the thing. Like I'm not sure if it's even worth it to type check these literals, man.
Yeah, man, they're stupid.
no, we're not gonna test the literals at all. We're just gonna go
No,
for it.
why bother? Who cares? If it's type checking, then who cares?
No, that's the thing.
It
We
type checked and checked 10% of the set, so it works. That's the probabilistic.
if
That's the
booleans are working,
probabilistic
right?
testing.
Oh no.
That's all you
Oh
need then.
man.
If somebody questions you, you just say, "Oh, I'm just saving resources here."
Lemos, what about the false, man? You're not testing false.
No, but I'm not gonna test all integers, man. You
Yeah,
think I'm a
so that's what
No,
I'm saying.
but
It's never
booleans you
gonna
only have
be.
two.
What is the other one? Oh, rational.
I mean, this is so useless.
Oh my god.
What is
Uh,
a rational thing, by the way? A string,
no, a rational is a rational number, which
which
can
in
be in
Haskell is
Haskell is this.
okay.
Uh,
Oops. And this is gonna be rational. Man, it's gonna be the same thing again. Like we had a session in Erlang which Nathan was not there. It was just Maget and me, and the name of the session is "Who Needs Testing Anyway?" This is gonna be part two of that. What other literals do we have? I already
Oh,
forgot.
please, no, over. It be over with literals, please.
We have only four.
Thank you. You could have just tested one, and but probabilistically, you would be right.
Describe. Okay, what is the next one?
That would be a good case for property testing because we could just feed
We
the
can
type.
do property testing.
Yeah,
We can do.
because we don't need to test all the stuff, right? We
Yeah.
can just send the type.
Um,
Oh man, that would be cool. Like a single build
Imagine.
random expressions.
like
Exactly. That's gonna be
kind
cool.
of because like the property that you would be testing on integer is too simple, man.
Yeah.
Like on the code, you would need such a like shitty
No, but
code
but
to
here's the
be
thing.
doing an
Like,
exception
no,
to
but
a
here's the thing
specific.
that like we wouldn't need to with property testing. We don't need to do L bool, L integer, L unit, L rational. It already builds all of that.
Yeah, it doesn't build. It
Oh,
doesn't build
oh,
like
okay, yeah.
that because it's not like, as far as I can tell, you cannot
Well,
ask to
it tries
make
to
any
yeah, it
sort
tries to
of.
make exclusion, right?
Yeah,
That's by exclusion.
and then we do like this, Nathan. X and then int.
Wait, no, man. You can do the thing itself instead of L integer. You do X, which is a L value, something like this. I don't know what's the
Oh,
type of
okay,
the
okay.
L
So it's gonna
value. You
be you
see?
want to do L
Yes.
e
What?
literal e
Yeah.
integer.
No, you don't
Oh,
need the
okay.
integer. Okay, you can put generic there, I guess.
Yeah, I don't
On
know.
the
I
integer.
have no idea how this is gonna behave, but this is fun. I really like it.
But how do you put the generic there on
Like
the
this.
literal? No,
No,
no.
the
Look,
generic.
look back there. I'll go back there. On the integer, how do you put the generic there?
How do you put the generic?
Yeah, so we can like test if he picks, I don't know, L bool, then he picks a bool. If you pick a rational, then it picks a rational, something like this. Because on that way, it will always enforce to be an integer,
I
right?
have no idea. Yeah, but this is what we want. This is the test for the integer.
Can't you just remove the integer?
And do like this? You mean?
Yes, I think you can.
Like this? I
No,
don't know if
no,
this is gonna
remove
work.
remove the second, remove the underscore.
Like this.
Yes, I don't think you need that. Okay, let's see.
No, but which property we want to test about
Yes,
illiterals?
I want you to discover.
Oh!
That's it.
What the?
Because the constructor uh, e literal, like that thing is not requesting anything specific, right?
I don't
Like
know. Let's try to do like that. Okay, it's not Emacs is not complaining about
oh,
syntax errors, which is
well, but
surprising.
that is not a testing, right?
What do you mean? No, that is testing. Look at this example. I want to see. I want to have a property in which I receive a thing. Maybe
Mm-hmm.
this is too small. In which I receive a
Okay,
thing,
better.
I receive a tail, and then I construct a list out of it, pick the head, and this should be equal to x, whatever x is.
Okay. Mm-hmm.
So I don't know if this is gonna work because it doesn't
Oh,
make
yeah, I
any sense
see, I
to
see.
me.
Yeah, I see.
I
Yeah,
think
this
what
does
we
make
need to
sense.
do is to do like this illiteral. Then we put
Oh, no, 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 no. Wait, shouldn't it be like this then? Like, let me type here. Shouldn't it be x, boom, e literal, and then y?
we can try all of them. We have the time. That's not a problem.
Shouldn't it be this?
X blah. Well,
Cause like one is packing the other. That's why I think it's weird.
okay. Let's try this first. Let's try this first, right? Let's try this.
That's weird to me, man. Because they're not types.
Wait,
Like
can you
that thing
repeat?
is not a because that's not a type. Integer.
Isn't
Is
that
that
a
a type?
type? Isn't that a type
No.
constructor or something like that?
No, it is a part. It's an element of a discriminated union,
Oh,
right? But
it's
it's not a
L
type
integer. I'm
itself.
dumb.
Yeah, but even though like that's not part of the it's part of the type. It's not a type itself.
So in your mind, this
No, because here's the thing. How do you do property testing?
this
Limit the domain you want to test. Now go back to the ST. Let's sort it there. There. So what you need to feed? You need to feed the type you need to send, right? Which is an expression,
yeah.
correct?
Yeah, in this
So
particular case, it is an illiteral of a literal, right?
so yeah, but you need to build a property. So what we are doing is building the things from illiteral. Illiteral is not a type.
Illiteral is not a type. It is a type constructor, I guess, right? It receives another type here
Yeah.
to be a type like this.
So how do we limit the thing? So first question. We can do that with property testing, but we need to limit the domain to only get illiterals.
Yeah, I think
But
this is
the
the
way
way.
you're doing,
Look at it.
yeah, but that's for defining the type, isn't it?
This is for defining the type.
Like the column.
Yes, the column is to define the type.
Yeah, but how can you do that with a member of a discriminated union?
I have no idea.
Well,
Wait, 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 wait. Can
that's
you
not a type itself.
I want to see
wait,
the
wait, wait?
representation.
Can you say it again? Because I think I have a cursed solution for that.
It worked.
Boolean.
It worked. What the hell?
Oh no, but wait, go back there.
Oh, it
Type
was not
check.
saved. Okay, now we have a problem. Cool.
Let me repeat to Nathan. Like we wanna limit the domain, Nathan, to only get the booleans on the property. You see?
No.
But on line 16.
Yeah, the here.
But here's the
16.
thing: you cannot do that because they're not types literal. They're just a type from literal, right? Oh, sorry, from expression. So
Yeah.
you should name expression and then you limit. I think you filter. I don't
I
know.
know a way.
I haven't.
I
What should I
know
do?
a way. They are called generalized algebraic data types. You can have a different type for each data constructor.
I think this error message means that Magetta is right. Not in scope. Type constructor class literal.
Yeah, it
Why
should
you don't have
just
access to
put
that?
expression. Just put expressional. Yeah. It will probably find a falsifiable garbage because, well, there is like many others that we didn't test.
Yeah, it tried.
Yeah, you see? Yeah, but it built, you see? Like it made a illiteral unit. So, wait,
Yeah,
that's not from the property testing, is
that
it?
is. It is here.
No, that's another test, man.
Not in
No,
scope.
wait, what? No, 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 no. It
Yeah.
is, man. Here.
Variable not in scope property.
Oh, you've been in here. Okay. Okay.
Yeah,
Property not
that
in
one.
scope. Yeah, you're correct. So I'm probably missing something. So
Quick
property.
check.
Oh, now we need quick check.
Okay.
Now we do need it.
Can you comment the other tests just to remove noise?
Yeah.
If we get this working, would be amazing. It's
Yeah,
like
instead of doing
that's,
like
that's
one test
literally
for a
lazy
true,
testing.
one test for a false, we can have one.
That's literally lazy testing, man. I love it.
What is the name of quick
Wait, but
check?
the thing that we are doing doesn't hold, right? Because not all of them will have that
Yes, I
type.
know. That's the point. We need to find out how to filter the
Yeah,
cases.
exactly. Okay, so I don't know the name, so let's YOLO it.
Wait, the problem is there that you want to specify the type from.
Quick.
Yeah, man, we can solve that.
I hope so.
Oh, okay, yeah. Sorry, we can. Well, we can, but would be
Okay,
really bad for the rest of the compilers.
Constructing, blah blah blah.
it is complaining about something that I just added. Is the error this?
Quick check needed, blah blah blah.
Do you have that specified on the appendices and stuff?
Yeah, no, we don't, but that's because I don't know. To build depends on your Cabal file. I never had to add quick check in my stack projects. So how do we add that? Test?
Don't we have like stack add dependency,
I
something like
think
this?
yes. Okay, but I think this is the problem because I think quick check is the only package apparently that has capital letters.
Oh,
Okay, so let's try
No.
this.
that would be Clown World. Yes, it is Clown World.
Variable not in its scope. Expression. No, X, sorry. Okay, we are doing something wrong then.
How do you do? Let me see again the syntax of this
Oh, wait,
garbage.
I know. It is because we need to receive X. Like this.
Oh yes, yeah. Makes sense.
No instance for arbitrarily expression. Yeah, in the first argument, namely property. Yeah, so we cannot do arbitrarily expressions, I guess.
And no, but it's not complaining about the expression itself. It's the property expression, right? Change that
Okay,
to integer, whatever.
change that to integer.
Yeah, like just send one
No,
to
I
type
do have
check.
I do have an idea, but again, it's personal code. Let me pause here. The syntax is right. As you can see here, the property test, uh,
X, XS.
getting
Okay.
construct a list, pick the head out of it, and check if this is equal to X for any sort of integer.
Oh, wait a second. You are typing the thing on the function call, not on the response. Does that matter?
Wait, can you repeat what you said?
Like you see where it's typing the element of return, not on the had, but I don't think that matters, right?
I don't think that matters also.
Yeah.
So what we need to do is to
Yeah,
discover
just
how
make
to fix
the
this.
generation of the stuff.
Yeah, and I have absolutely no idea how to do that.
Well, let's look at F sharp just to get an idea.
How to make property
FS
test.
check. I think it was arb, how they called it, which from arbore. I guess. I don't know. I'm just guessing. Arbore.
Just guessing.
Generating test data. Oh, of course, in F sharp it's a computation expression. Of course.
Makes sense.
Oh man, everything
I'm
makes it. Oh
surprised
man.
you were expecting something different.
Yes.
Oh man,
Oh man.
I'm a
Look at this, man. That's so simple. Oh man,
condition.
I love it.
Import quick check. Then there's a function called quick check which does this. Wait, we can do it in this manner though.
Oh, let me see.
We can create a function that picks an integer and
Oh, but
returns
it's just checking by the signature, right? That's all.
No, it's not. Look.
No, yeah, by the signature, which is integer
Yeah,
bool.
no, but then quick check can realize by itself. We don't have to instantiate it because if we don't do it in this manner, I think we're gonna have to eventually do the arbitrary stuff. Like
Yes.
we're
Yeah,
gonna
that's
have to
what I was planning
instantiate.
to do.
Well, we
Yeah, but
can.
if you want a specialized test, you're gonna have to do that anyway.
No, we don't. That's what I mean. I don't have
Okay,
to
you just
because we
want
can
magic,
make it this. No, it's not
literally.
magic. It's like this.
It
Look,
is magic, man.
we
It's
have a
automatically
function
generating
that picks
test
an
each magic.
integer and returns a type of result, right?
Yeah.
Type of result. Then you pick the integer, you create in you call type check using an literal, using an um, using an L integer, passing x, right? And
Yeah,
then
but that's
you
still what is different from doing what we were doing. We're just checking the integer. Like that's not what we wanted.
no.
Oh, dude, we're stupid. Just change the integer to what? Go to st again, please.
est
Change the integer to literal. So
change the
it
integer
receives the
to
literal.
literal.
Yeah, just change the integer
Change integer.
on the signature.
Oh, on the signature.
Yes, to literal, and then x is now a literal. So you just put a literal x there.
Yes.
Okay, now I think that would work.
No. But we still have the same problem, right? Because we want
Oh,
to.
that you need to make it general.
Yeah,
Yeah.
we would have to make it. Oh, how you gonna map whatever is x now to
Yeah.
whatever is this
No, but wait,
result?
we. Yeah, property test. You need to match something.
Yeah. So that's what I mean. We can for at least for
Oh, but
now.
wait. I got an idea. Go back there. Go AST again. Let me see. An literal will map to a type that is like t unit, t integer, t rational, t bool, right?
Yeah.
What about we do just type instead?
What about we do just type?
Yeah.
I wouldn't be comfortable doing that because maybe we're type checking it wrong,
Yes,
right?
I know. But
Yeah.
then, like, there's no point on property testing that way.
No. There is a point. Let me just test this for a moment. Then we could do that as a boolean, right?
But
And
man,
then
like, on that way, you're just variating the integer, which doesn't matter.
no, for us it matters. We want to know. Okay, we have two booleans. In this
Okay,
case,
the
is
question is there any integer that breaks this?
yeah. That's the
Dude,
question.
that's stupid. You gotta check the type, not this.
That's stupid, he says.
Yeah, man.
Okay,
Like,
It
that's
kind of is, man,
a hundred
because
tests, it passed.
yeah, but you're just variated the integer, like 1, 2, 3, 4, 5. Like, it doesn't matter.
No, but look, no, you're. I don't. maybe we have a
Lemos,
problem
Lemos,
with what is property testing, right? So this is a property of any list, right?
Yes, and in
Lemos.
this
It's
case, makes
regarding being
sense.
useful, man. Like that's not useful for us really. Like our code would have to be something that is either doing a computation on that or could have an exception on that. So our code would be so fucking cursed if you are type checking one in a different way.
No. But this is because you guys are not seeing the big picture. Because having only an integer sounds silly. But you need to look from the perspective of when you have more complicated stuff.
Yeah, but we don't there.
Yeah, but we don't. It's just an integer.
Well, but in this case, I don't see the
No, but
point of doing property
no,
testing
no,
then.
no, 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 but no. That the point also does not hold because what you're gonna make more complex? Okay, you're gonna make more complex the things that you're interrupting, like the integers, the booleans, whatever.
Yeah, pretty much.
Yeah, but like at that point, why you're doing property testing then? You're not variating anything like the what matters, which is the types.
Well, if I don't know how we're gonna make a property test.
This makes sense for evaluation, I guess. This could work on evaluation, but for this,
Okay, I kind of agree with that now.
but for types, I think that's pointless. The point is, we gotta know how to limit the domain because if we can,
No,
then we
this
can do
this
the
needs
test.
to be a thing. I'm 100% sure. So we need a
What needs
way.
to be a thing?
We needs to be a thing that you can. Oh, I have this test right here, right? I have this. Um, I want to check a specific property, but I need this to not be any sort of expression, right? I need this to be a
Yeah,
specific.
that's yeah, those are gadgets. Like he receives a type variable, but you how can I say it? Well, you saw already the syntax lemons when you were looking at some Haskell code. But basically, each data constructor will return a different type because they will return the same type, like father type, but with a different type variable, right?
Yeah. So how do we make this happen? That's what I don't know. This. Okay. So let's think a little bit about this. We have a problem though.
Hmm.
What is this saying? I'm going to instantiate arbitrary for 3 with a parametric value a if a is also arbitrary, which in that case it is
Mhm.
because it's numbers. We don't
Uh-huh.
have that because our literals and our expressions, they don't have a parameter here. So what I'm
Yes.
thinking on doing is the following. We're going to do arbitrary equals do. Then you're going to pick. Oh, not all literals have a number or a rational or a boolean.
Yes. Can we pick from a list?
Can we pick from a list? What do you mean?
Because then we can separate all the things that we want, like for example, from the literal. No, sorry, from the type, and then we can limit, right? We just expect these things here.
I have no
So
idea
we,
the answer of
so
that
we can
question.
choose from only that set. Like, we can do that, I guess.
Okay, he did something, yeah, sized arbitrarily. Okay, so what he did is he picked this function here that he described a little bit before, which is the choose one. Yeah, choose, right? That picks a tuple of a random
Mhm.
and generates creates a
A and
generator. And then he used that function in here, right? So it picks, oh, this is probably the interval. So you pick a number
mhm.
m and then 0 from m and a half of m.
Uh-huh.
Then you choose, you create a generator out of that, you call that n. Then there's a function apparently called vector of that picks the generator. And this function is recursive because this is a binary tree apparently. Uh, which calls the function again but dividing the number by 4, the original number.
Mhm.
And you call that again and again until you have the entire tree, which is okay. Yeah, but our case is pretty unique because our case is not like this, like tree A, you see? Our case, it has like It is just the
It's just
type.
nested, but that's it. Yeah.
Yeah, but it doesn't have. We are not saying, oh, this is an integer and this is that. This is that. Okay, I have
So
this.
how can we arbitrarily get just literals first?
That's a good question. How can we get literals?
How can we selectively get stuff?
How to use arbitrary function?
Let's
Oh, here,
see.
simple type.
Let's see. All right. You just specify what is the type you want. Okay, that makes a lot of
Positive.
sense, man. Look there. Positive X.
Yeah. But how are we gonna make for all of them? Them. You see what
Oh,
I
what do
mean?
you mean?
Because in here there is a much like a coincidence that this is an integer and this is also an integer, right?
Uh-huh.
And it's also a coincidence that this is just a product type. This is not a sum type. How do you make for the sum
Mhm.
type in a manner that it is different? Like we cannot do this all the time because maybe it's
And
going to be an integer, maybe it's going to be a rational, a boolean. You see what I mean?
oh, I see. Can't we just do E literal and then X
Ooh, we
there?
can try. That's a good test. Let's try that.
And then let's see what it does.
Okay,
Yeah, this is
so
actually a cool. This is actually cool testing. It's not retarded.
let's try
Literal.
literal.
E literal.
Literal. So this is for an
Yes.
expression.
Yes, sir. I want to go all the way to the top.
Um,
Remove the positive and just return that crap.
we're gonna return an
Yeah, return X.
return.
Yeah, just return X.
No, this is not gonna work. I guess.
Why? No, don't test it yet. Just return it. I
No,
just
it's
want to
not gonna
see
work
the.
because X has type literal.
Yeah, what's the problem? Just change the arbitrary, man. Dude, just run this. That's what I was talking about. Just run the REPL and run this thing to see what is it generating.
No, wait. You know, don't see the problem. The type of this is incorrect because the type needs to be expression.
I know it is incorrect, man, because you are unwrapping the shit. I'm just saying, just print. I want to see what it is generating.
Well, we can't print, but
But just change the expression, right? Change the expression. It's gonna fail.
okay. So it's expected a gen expression, and we are returning a
Mhm.
gen literal, which makes a lot of
Yeah, so
sense.
just change to literal. That's what I'm saying.
Just change to literal.
Let
Change where?
yes, that.
Here?
Yes. But literal. I just want to see what it is doing. That's all.
Still wrong.
Oh, but wait. That then it's breaking what? The oh, okay, I see the arbitrary changes. It's not a
Yeah.
return type. That's not a return. Oh man, that's bad. Okay, so just change back to expression. Oh, but we're stupid, man. Just change back to expression.
Okay.
Oh man, we're stupid. Okay, now just wrap that in expression. Illiteral, sorry. Yeah.
No
And why?
instance for with a failable pattern. Failable pattern. Monad fail. Arising from the statement with the failable pattern illiteral. Yeah, I think we're gonna have to dig a little bit more on
Ju-
this
Can you remove
because
the illiteral and just do X? What is it? It's an expression, right?
yeah.
And then just do if.
Man, isn't
Can you
this
do a case?
recursive? Like, look at this
No.
crap.
But wait. Do a case. Now do a case. If it is an illiteral, then you return. Otherwise, you don't. Can you do that?
Yeah. Wait. If it's a illiteral, I return.
Yeah, return the illiteral X.
If it's something
Otherwise,
else,
you.
I don't know. Here.
Yeah, something like this. Okay. I expected that the exception there will fuck up everything. But anyway, let's see.
What the crap? Yeah, it's lazy. We can't say this is correct.
Yes. But anyway, just try to run that thing.
Okay, so wait, no, this worked. No, I didn't save this, right? Oh, I didn't save. Okay, yeah.
No, but you didn't specify the instance there, right?
The instance.
Yeah,
And
like
it's done, bud. It's done. It's an infinity loop, which makes sense.
no, but here's the thing I wanted to do. I just want to generate the things. I don't want to run the test yet. I just want
Oh,
to see what is it generating.
let me think.
How do we run? I think the guy was showing there on the paper on the article paper and just crazy. Stack something. Stack builders, that one.
Just one sec. There is a post. Because this is the question, right? Quick check arbitrary, ADT arbitraries for some types. This is kind of what we need. There is a quick check arbitrary package. Improve arbitrary value generators for ADTs. Interesting.
There an example somewhere?
Yeah? Generic arbitrary. This is exactly what we need. Look!
Yes.
int, string, yeah. So these are different.
Mm-hmm.
And any type that implements two ADT arbitrary must also implement arbitrary. These examples all require that the data type is an instance of generic. Oh, this is how you do it then. You need to derive generic.
Oh, I think I see. So you basically do. I don't know what the generic is, but I think you need to just build for each independent thing, and then it just glues it all together.
Yeah, that's probably it. Huh. So you need only these two and deriving generic. Okay. Okay, I can get behind that. So let's put quick check ADT in our package thing. Oh man, I'm getting excited now because I never did this. This is the first time
With
ever.
testing. That's a weird. That's a weird thing to get excited for.
Oh, it's awesome. Generic.
But you need the other ones as well, right? Like, yeah. And you need, I think, JC generic, something like that.
Derive generic. Okay. Okay. I'm gonna assume this is gonna work just fine. JC generics also.
And I think you also need the arbitrary ADT garbage.
I
Yeah,
also
just
think
copy all of this.
so. We'll pick this. Okay. Then you copy this code like that and replace fruit with, I don't know, literal, and then you do the same with the literal but for expression. What are you complaining now, my friend? Data
But yeah,
types.
that's what I wanted to do. Generate, you see? So we don't have to build the thing. Just
Yeah,
want
I
to see.
see. Yeah, I do. I see. I see.
Generate
No
arbitrary.
instance for. Oh no, we don't have text. Text does not implement arbitrary. You gotta be fucking kidding.
Oh,
Oh no.
change the string instead.
Oh, that would be bad, man.
Yeah.
I can't believe. So arbitrary text.
And then we discovered
Haskell.
there's another dependency.
Oh, here.
Oh no, you gotta be kidding me. Oh no.
Thanks for that.
This is getting out of hand, man.
It is specifically designed for the text
Yeah.
package.
People people are true.
Okay, I don't know about these zeros anymore because maybe data text arbitrary. Okay. Import data text. Fun. This is still complaining. Cannot use arising from the use of that. Oh no. Efficient pattern when you code text type. Orphan instances. Can I generate arbitrary strings? Element. Yeah, this is string. I don't want string. String is bad. So this is the thing that we checked there. Quick check text. Okay, I'm not gonna trust Emacs on this one. Just go. Ooh, my terminal is done. You see that it's not blinking?
Yes, it's tired. It's please enough.
Oh, okay.
Yeah, so you.
Oh, type also needs generic.
Oh yeah, I even said that.
Yeah. Okay. Next
Yeah,
one.
but it's the same.
No instance for type. Didn't I save it? Yeah, I saved it. Oh, this also needs generic.
Oh yeah, everything that touches that, right?
Everything that
Yeah.
type has, literal has, expression has. Okay, this should be close to it. A little bit more. Okay. Still complaining that arbitrary type is not there. Oh, of course it's not. I'm dumb. I need to copy paste this.
Oh, for the others, right?
Yeah,
Type.
for type. And for T4O also, by the way.
Let's do Ctrl D there. It's easier.
Control D.
Yeah, Ctrl D.
Okay.
Yeah, it's there.
So it's gonna be for T4O info. Oh crap. Control D. This will be type.
And I think that's it, right?
Control G didn't work. Yeah, that's it. Oh,
Oh, oh, oh, oh. Okay, now try to run the generator. Try to run the generator. Damn it, dude. If it works,
Imagine this
I'm gonna.
works.
If this works, I'm gonna be so.
Well, but there's a problem
No,
now, folks.
use the generator first. Like, we still need to filter. We're not doing that.
No, we still need to filter. That's correct. But let's first try that. The error before was that we didn't have it, right? We didn't have arbitrary. Now we do. Let's just see if the error the test will fail. For me, that's something. The test needs to fail, which did.
Yeah, look at the crap it generated.
Okay. This is progress, though. This is progress. We need to discover how to filter stuff now.
Yeah, starting to think like testing this with dependent types is somewhat pointless because you're already doing those propositions while you code.
I
You're
am
already
already
like,
doing.
yeah, you're already doing stuff and proving while you code. So you don't even need to test all of this stuff. For example, like a type, can you go back there? Let me show you an example. Yeah, like t variable, you see that's empty, the variable? That's wrong. We shouldn't allow that. But then like we will need to do something like in the domain to limit it to be like a set of strings with greater than one, right?
Uh,
Greater with size with length more than one, more than zero.
yeah.
But then like in property test you can already do that. Like just defining the new type for that. Property test, I mean the dependent types. I mean.
Well, I saw the other day that we have we have a non-empty package. See here?
Let me see. What is that? This one element identical to.
If we
No,
have
yeah, but no,
this for
yeah, but
that,
here's the thing. Like that is one specific usage. We could do all of the stuff that we are doing
oh here,
already in just the types with text. Oh, QB.
um, well, I see what you mean that, but I don't know how we're gonna tackle that. So I think you're suggesting to not test this then.
Yeah, for now, like there's no way. Like I'm just mentioning the problem, just raising it here.
No, that I understand. Um, but that's the thing. I kind of don't know how we're gonna test this. I guess. Let me try something. Right? Because you said something important, which is that. Um, okay, what about in vitro? I don't know if this is gonna work, by the way.
Huh? I don't know, man.
And this should be, I don't know, whatever.
Yeah, but
Type write whatever. What are you complaining now? Couldn't
yeah.
match expected thing
Oh,
expression.
illiteral doesn't exist. It's okay. Never mind. That's an expression. That's right. So it should match. Yes,
Okay.
that's right.
So X, I am saying is a literal. Emacs is even understanding is a literal, right?
Yeah.
Oh, it's
And
because
it's
type check expects an expression, and I'm dumb.
oh yeah, that's true. Yeah.
Okay. Okay, but there is a solution for that, which is more parentheses.
Yes. That's why I was
In vitro.
mentioning Lisp. Think about it, Amos. Lisp. Oh, I don't
Now,
think you can put the underscore there.
wait.
Yeah.
Found hole in the first thing there. Okay, but what if I told you that we expect something that is a type? Okay, now it's complaining that variable not in scope. Um, okay, I have a solution for this, but it would be very hellish, which would be to
Oh.
separate the types into like, oh, these are the types for the literals. You see what I mean? And by
Oh, I
the way, I
see.
didn't I didn't
Oh
hear
no.
Nathan for like a while.
Oh yeah, I think that is I don't know
I'm not
eating
live.
açaí probably.
Man, that was very precise, and I was doing that earlier.
That was very precise.
Like 2 hours.
Or as Benet says, Jussara. That's the real name for açaí.
The
If you speak açaí like that, I'm stopping talking to you right now, Nathan.
What are you expecting? No instance for arbitrary literal. What do you mean, brother? We already defined that the literal is fine, right? Oh no, I didn't. Oh no, I did. It is here. Literal is also doing the generic stuff. We have the drive generic, which is cool.
I don't know
Rising from
how I
user.
got it right that you were eating açaí, Nathan. Because I'm watching you.
I don't know. Okay, but this was already wrong though. So it's saying arbitrary literal rising. No instance for arbitrary literal. No, what do you mean? I'm so confused right now. I
Everybody's confused, man.
we are doing this in here, right? I'm not
There's
crazy.
a spell. I remember you made me remind. You reminded myself of a spell in Oblivion. Wait, let me call it Oblivion spell. Let me.
We also pick this and put, I don't know, here. Then the type ones here. Oh, Emacs is crazy. Okay, so that's not a problem with what we are doing.
Not only Emacs, Limbs. Not only
Emacs is just done. He doesn't know what to do with this thing. But it's saying that it's falsifiable because it tested with literals with an integer and it didn't get the unit out of type checking, which makes a lot of sense, right? Makes a lot of sense. So we are very close. We are very close. We just need to figure out how to say, okay, it's not any kind of literal. It's not any kind.
Here, let me see the illusion spells. I'm literally going after the spells in Oblivion just to remember. Rage. A Voice of the Dread.
Man, how much did we spend like trying to test lead?
Literally.
How much time, man? Like,
That's why we're late, man. If this is actually a pitch, if you think about it. Because we got a good language and then we just want to do everything.
like we are throwing our leverage to the trash, man.
Yes. Um, and I'm looking at Oblivion spells. I'm not gonna find this. What the heck? Destruction, mysticism. I think it was mysticism. Let's see.
Well, but this was a fun experiment because if you think about it, Nathan, we already kind of like we 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 know how to test stuff. Like we had
Can we
tested
test?
before working.
Can we test the System F, which was the original thing?
Yeah,
Can we test the system F stuff?
Let's just test that. Yeah, please. Let's test identity. I can't even speak anymore, man. I'm just.
you could, I don't know, like comment this so we can like uh, continue another time, and let's just like test system F and go home, man. Let's end the pain.
I
Let's
like the
end the
go home.
pain. Oh man, that's so great.
I like the go
Um,
home. Gotta work on my eLisp database.
um, okay, so what we want to do? Want to test again? Because I already forgot.
Identity function. Do System F, because this would be like the System F block.
Okay. What is the first one that we want to test? Identity function, right?
Mm-hmm.
What the?
Oh, you selected one line that wasn't commented, so it got inferred from that. Yes.
Okay.
Indentation is wrong, by the way.
Okay. So identity function.
Did fix this indentation, please, Lemus? Oh no, it's right actually.
It is right.
Just giving me a tilt
Okay,
because
so what
it's.
is an identity function, guys? Can you guys tell me?
Well, look at Haskell's definition of identity. It's the same. You just have a for all t, and then you have t.
It's a t for all, and then t for all
No,
info. Then we're
yeah.
gonna put the text here, which means that we're gonna have to have overloaded strings again. Okay. So for
And it's an
this,
arrow, right?
now it comes the type, right?
Before that, it's an T arrow, right?
If I'm not mistaken, it's the for all first, right, Nathan?
Or
Or I'm
after. I
crazy.
don't know how it's being wrapped on System F. For all info.
Yeah, it's. I think now the arrow comes now, I
Yeah,
guess.
it's the arrow afterwards. Yes.
Okay, so now it comes an arrow, which is T arrow,
Which takes a day.
which takes a type, which is going to be a type variable, right? T T variable
Mm-hmm.
a,
Yes.
another T variable a,
Yes. China. I think that's it.
and then we eliminate all of that.
Oh man, like
And
Discord removed the emojis thing from
sorry?
here. Discord removed the emoji confetti.
Oh really?
Yeah, I don't have it here.
I also don't have it here. Okay, they
Yeah.
removed. Okay. Okay, but isn't this the this is what we want? This is the type, right? This is not. This
Yeah.
is the answer of the type checking. Or am I going crazy?
No, this is the type of the function. The
Yeah. So this is the type. So this should be after the should be.
yeah, but should be what? Like that's the thing.
Now we're gonna write the expression here.
Okay, I see. Yeah.
Right? See? Okay. So what expressions do we have? Uh, Types. How do you construct identity with expressions? It's like this.
It should be an abstraction.
E type abstraction.
Yes.
Okay, so E type,
Actually, no, right? It should be just an abstraction. Oh
just an
no.
abstraction.
No. That's right. It's an E-type abstraction
E
that
type,
takes another abstraction. Yeah.
yes.
Is that right, Nathan?
The E type, I think this is where the A comes in,
In the text, yes, and then it's an E-type abstraction.
and then it is an
Then
abstraction now.
it's an abstraction. Yes.
Yeah.
Yes.
Nathan, are you there?
Yeah.
Okay, the confetti is there. Um, should be an A, right? What is the type? What is the type of this A? Magetta?
Just one thing, like that is the text, right? Not the thing. So it should be X there,
Should
right?
be. Oh no, should be. Wait,
Yeah, it should be another thing, not A, because A is the type.
A is the type.
Yeah. And then now it's a type variable.
Uh,
But I'm not sure if it's really a problem having the same name. That's a
Yeah.
good thing to test.
Yeah.
T variable, and here comes
And
the A,
then A, and then you have the
and then
body.
the body, which is gonna be just A. No, it's
X.
gonna be another expression, but it's an E variable.
It's just a E variable X. That's it. Yeah, that's a good test as well. By testing if it.
That's only a problem for parsing, I guess.
Mm-hmm.
Can I make this a little bit better? Indentation? No, I can't. Okay, so something.
Isn't it
Precedence
the should
parsing
be in
error
the
cannot
right?
mix should be.
Should be, should
Oh,
be.
there should
There are
two
two should
should
be's.
be's. Okay. 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 What are the odds?
Okay, the test compiles so it works.
What?
Oh, it works, damn it. What the heck? Alright.
Let's test what Nathan said.
Yeah, change the way.
Actually, let's be proper software developers and make another test.
Yeah, but we're not, right? I am at least not. Yeah, I can totally say that.
Same names, I guess. Oh yeah, it works.
Damn.
Okay, next. Okay.
Commit this, please.
Now you need to apply that.
Yeah, let's try to do an
Let's
application.
try to do an application.
I guess it would be useful for you to like put some of the values inside variables, right? Inside the describe scope, so you can reuse and stuff.
Okay, we're gonna wrap this now. We're gonna have another
Yeah.
thing here. You're gonna wrap with an E-type application, right? Is this correct? What I'm saying?
I don't remember what was the E-type application for.
It is for you have an expression and a type. So is when you have a parametric application. Like the application is not waiting for an
Right.
expression, it's waiting for a type.
True. Yes.
So
Yes, sir.
I don't know. So we are waiting for a type. So I guess we're gonna do, I don't know, t integer.
Mm-hmm. That's it, I guess. And then you wrap in an application, right? Inside the thing. Like before this E-type abstraction, E application. Oh man, this is getting confusing.
Hey, test only that first and match that against the T arrow with integer.
Wait,
Oh yeah.
can you repeat?
Yeah, a T arrow from integer. That's how it should be.
Wait, is this?
Yeah, this is just applying the thing to the type of the E-type abstraction, but we need to apply the value.
And
Let's
I
not
did
do
it wrong
that.
here. This is x. Okay.
Let's just
There
apply.
would be a good case for the property testing because there you can go through all
Yeah.
the things.
Anyway, can you guys repeat for me what
So
exactly?
this should be an arrow from the integer to the integer.
Um, yes. Okay, I agree with that. This should be from the
Dude, if
integer
it
to
just
integer.
works, I'm gonna be really surprised. Oh, thank you. We have a good language. Oh man. Yeah. Okay. Having a good language really makes a difference. Man. Look at this. I'm literally punching the next person that says, "Oh no, types are useless." Oh man.
I record by get the punching itself.
Oh man. No man. I say that jokingly. I say that jokingly. Anyway,
Well, it works.
let's apply that now. Let's apply like two.
True. What do you mean?
Yeah, a value.
No, but that's not type checking testing.
Yeah, it should type check to an integer.
Wait, I'm confused.
Like apply true to this E-type application,
Oh, okay.
and then it should evolve to true.
Lemos, use variables, man, to do like intermediate values, right? Because
Okay.
Yeah.
Okay, I think it's a little bit more readable now. Let me change in here also. So
I'm kind of thinking this would be really fun to be done in Lisp. Just thinking.
he just says something great, which is that he's gonna punch someone that says the types are useless, and then he says this.
Yeah, because the language is cool. Like, that's it. It's like a meme, yes, but that's the purpose.
man, we are repeating all the same expressions again and again.
I can't use Control D. That's why.
No, I mean, what I just said, use variables to store those things that you are repeating, right?
Yeah, just store like A, B. Yeah, that doesn't matter. Ignore that. Keep going.
Look at the size of the line.
Oh, now I understand. Okay. Oh, yeah, we have a point. Not doing it though.
Hey man, who cares?
Can't use Control D. Sucks. Why can't I use Control D, Nathan? Nathan, no, Magetta.
You need to select Ctrl. Yes, now you can. Ctrl D. Yeah.
Nice. Okay. Okay, what is the test that you guys want now? Apply a number.
Yeah, just apply a number to this garbage, and then it should be just a t integer.
Okay.
Uh, we could also try an error, right? Like you try applying. But that would be stupid.
Okay, so this is a value applied
Yeah, value
to
applied
identity function.
to up. Yeah. Okay.
Okay, so we're gonna just wait. I
So
am
just wrap into an E type E abstraction. Yeah, application. Sorry. Oh man, getting confused here.
and as far as I can tell, this is waiting for expression, another expression. So it's gonna be a illiteral.
Yeah, man, this is so cool. Like we could do this without any bugs so far.
Knock
I
on wood,
did,
knock on
man.
wood, everybody. Uh, L integer.
Linteger.
2.
Then it should be integer.
And here we should have just t integer. Okay.
Try to do the following now. Try a normal function that receives ID and then apply everything.
Oh man, that is like very.
Wait. Let's start slow. You want something that grabs a t arrow and applies that something
No,
like
no,
that.
no, no. Wait. You have a just 1 second.
So you want to pass that as a high order function,
Yes.
so you can need to match the type of the abstraction, right?
Wait. Do the apply function. That we are include this case, I guess.
No, but the apply
Yeah.
isn't application. Or I'm going crazy.
No, apply like I receive A to B and A and return B.
Oh,
But what I
okay,
was
okay, okay, okay,
yeah.
okay, 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 okay,
But
okay.
what I was saying initially is to receive a argument of ID, right? The ID type, the T for all stuff, and then applies that, right?
Uh, holy crap! We only have currying, so I'm gonna have. Oh. Okay, so it's gonna be an IE application of an uh, another E application, I guess. Is that correct? People, people, Nathan.
Oh,
Sorry.
wait.
Uh, I want to receive two things, right? I want to
Sorry, I'm back.
receive two things.
What do you do?
This is the function that Nathan wants. Mageta. F A F A. No. F A. Yeah, like that.
Mm-hmm.
So what I'm trying to understand is this is an E application, right? But it is an
Yeah.
E application of two things, right?
Which are E-type abstraction. No, sorry. Which are by themselves E-type abstraction. Yeah, that's right. Is that right?
Wait. No, I am
Like
wait. I am
the
correct then. It is
application.
any application of any application. Yeah.
Yeah.
Here it's gonna have
Hey,
the
hey,
A.
do
The
the
A
following.
is gonna be here.
Uh, delete
Next.
the delete the application for now. Do only the abstraction. Then you can like apply it, right?
Yeah.
Okay, abstraction. We're gonna call this F. Now it's the body, which is another E abstraction, which is A. And that we're gonna apply. So it's an E application now, because that was the body. We have two expressions. Here it's an E variable, A, and here it's an E variable, F, I guess. Now that we have the entire abstraction pipeline, we need to apply stuff. So here,
You still need to declare the types and the type abstractions.
I still have to declare the types and the types. Wait, I'm confused. Where?
Look at the type of abstraction.
Oh, I do need. Yeah, you're correct. So this is a T arrow. What the? Okay. Okay, so this is a T arrow. That T arrow receives what? Two types. Okay. So let's go integer. Why not?
Oh no, then that's not the function apply, man.
Yeah.
I don't understand what you mean.
Apply generic.
Generic.
Yep.
Oh, type to type you mean. No, wait, what? I'm confused. Can you repeat?
What is the signature of the function the line 19?
It can be a lot of things. I'm suggesting
No,
integer
no, 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 no,
sentences.
no, 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 no. It cannot be a lot of things.
No, it can. Can be an A2A, an A2B, an integer to
No, no,
integer.
the function. Only the function there between parentheses. What is the type of it?
It is a T arrow that picks another T arrow, and whatever is A.
Can you write the type for us in Haskell?
Yeah. So what is the type of the thing in parentheses, right? It is a. I'm gonna. I don't know. Abs for abstraction has the type A, B, A to B.
Yep.
Yeah, I'm
Mm-hmm.
proposing to not do that. To do just integers to be easy to write.
The point is testing the.
Dude,
Oh,
just
okay.
doing variables first, because like it's very easy to get lost on this thing.
No, it's not about getting lost. It's because wait, can I
I am
break
lost.
this?
That's the problem.
No, I can't break. Let's do
In
what
Lisp, you
Anton said.
could. In Lisp, you could do that. Do you remember that?
Okay, so is this?
Yeah, man. I think instead of doing in the Lisp and just miming, I think I should do in Common Lisp, right?
Oh yeah.
I guess we should do in App Star, man.
Yeah.
uh, what is this? Uh, this is a E-type
Folks, I
abstraction.
gotta have dinner. I'll be back in a bit if you're still here.
Okay.
Anyway, I'll be back.
No. This is a T arrow. Yes. That goes from an E-type abstraction. Is that right, Nathan?
Wait just a second. What? No. No. There you will be using the type variables.
There I will be using the type variable. Oh, no, makes sense. Makes sense. So this is t variable a and goes to t variable b. Correct. Okay. The body is e abstraction. What are these weights? A text and a type. Okay, so it's a t. It is another t variable here. Oh my god. Okay, we should change these. So it goes from type A to type B. Okay. Then the value A has the type A. And then this is the abstraction. Okay, so this is the entire abstraction, I guess. Okay, so then the question becomes, what is... Okay, the body is this. That seems correct, right, Nathan?
Yeah, so.
Okay, I'm gonna call this body. Body. Okay. So what do we want? We want just to apply abstraction, right? Abs. Am I going crazy?
You are not declaring the type variables.
I'm not declaring the type variables. You mean? I think I'm tired.
Type abstraction.
E type abstraction. E type abstraction. Oh, declaring the types. Okay, makes sense. Makes sense. Makes sense. Makes sense. So what would that be? E type abstraction. Now we
Oh,
can.
that's part of abstract of ABS, right?
You mean in here? Abstraction. Okay, I am declaring them. So F. No, not F. A. Type A. Right? Is this correct?
Yeah.
Okay. Then we're gonna have another one. E
Yep.
type to type B. What about now? Is this correct? Nathan?
I guess so.
Abs. And this should be a t variable. Type B. Correct?
Uh, uh,
I'm crazy.
yeah, you're really crazy.
I'm crazy, okay. So what this should be then?
Yeah. The for all type A, for all type B, receive a arrow of type A to type B, then an arrow of
Oh, I
type.
see. I am crazy because I'm evaluating on my head. And this is not evaluation. This is type checking. Okay, makes sense. So it's for all um, t for all info for all type A's T for all info. For all type B's, we have, what do we have, Nathan?
The error, right?
T arrow. Why T arrow?
Because it's a function.
But isn't that a function? This is the type, right? This is the type that we are trying to make. We use the for alls there. For all A, for all B. Like, I'm gonna create a syntax here. For all B. Something like that, right? Something like this would be like this in Haskell, I guess.
Mhm.
Is this correct?
Yeah, but that's the thing. As we are doing the AST, right? We have the T arrow. It only has like two sides, right? Like input and output.
Yeah, we're gonna have two
So
occurring now.
yeah, you are missing some parentheses, right? When you are doing the AST thing, like it's not explicit in the way you wrote.
No, it's not. It's
What
not. It's
is?
like an A to this, which in itself
No,
is.
no, 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 no.
I'm
You
confused.
cannot remove that parenthesis that you had before.
Okay, that makes sense because of F is like this.
Yeah, but that's the thing. Let me see, man.
Isn't
Take
this a T arrow
that.
that receives another T arrow and returns another T arrow and the
Yeah, yeah. In between like A and B, I guess that's where you group
yeah, okay, makes sense.
like the other A and B, right?
Okay, so let's create this guy here. So it's all of this. Okay.
That's quite funny, man. Like they are the same thing. Like you receive A and B and you return A and B, but they mean different things. Huh, that's nice.
Okay. So this guy receives a type variable, correct? Which is type A, and T variable type B,
Yeah, and the right side is literally the same.
and the right side is literally the same. Well, you're
You
correct.
have
They are equal, but they mean totally different things.
yeah.
T arrow, T variable, oops, and T variable type B, and I forgot that I changed the name of this guy to type A. Whew. Okay, what about that?
Let's go.
Okay, oh, of course, right?
Ah,
This doesn't, isn't valid. Ooh, okay. Okay, so I should have done that before. I think because this is an inlet, we don't need the outside ones. We need it because of the right before. Same thing here. Same thing here. Now we have this as a problem.
there is something funny with apps there.
Okay, done.
Oh wait, let's just check those parentheses, man, because
Yeah, they are still wrong somewhere.
that disaster. Oh.
This this is correct. Okay. This should be correct as well. Yeah, couldn't match expected. E abstraction is applied to few many arguments probably. E abstraction expects what? It expects three things. We are passing only one.
It's really
We are passing only two actually. We are passing the f. Now, what after the text? Should be
the
a type
type.
and then an expression. We are not providing the expression. Right.
So probably this parenthesis there is wrong.
Okay.
No, I don't think you have this last one.
No, but it is complaining. We are lacking a parenthesis at somewhere.
Yeah, but let's see. The outer abstraction has type abstraction has type A and an expression,
This
right?
is not closing.
Oh
This is
yeah. So let's see. The inner type abstraction has type B. Uh, yeah, you need one as the last one, I guess.
no, wait, but this is kind of weird because this thing should be a type and then we have an expression. The expression is the body, correct?
The expression
Yeah,
is
look at this type here. This is the body, correct?
like I know that you are missing at least one as the last one
No,
there.
forget the
Then we
parentheses. Forget the parentheses for now. Just look at here. This is the
okay.
body, do you agree?
Uh-huh.
Yeah, so the body we already have here. But which means that all of this should be a type,
Back.
which is
Oh, you're
not.
still that crap, man.
Which is definitely not.
Wait. Yeah, but it is not. Indeed. Look the type arrow parenthesis.
Oh, this is the parenthesis that is wrong.
Yeah.
Ah,
Yeah.
crap. Okay. Why are you two still complaining? This binding
Why?
shadows the existing prelude. Oh, because there is a function called
Oh,
absolute.
absolute, right?
Yeah. Okay, moment of truth. Aha!
I guess you are
Let me
too
see.
excited, Len.
So
Aha!
let me see, and pay attention. Body is just an application of F to A. Abstraction, it is just an abstraction, a for
Actually, I'm
all
gonna.
abstraction.
We are being too dumb. We should put the functions here. Uh.
Oh. That's
Oh yeah,
a
yeah,
lot better.
yeah.
Okay, this is the one.
Oh, so much cleaner.
What is this one? This is when we are doing an application. So this is for all A returns A applied integer
No, come
applied
on, man.
applied
Come on,
string.
man. Come on, man. Are you really using the dollar?
Oh yeah.
Oh, fuck.
Okay, with this one, uh, for all A.
Yeah, the dollar would not work though
No, it's
on integer.
this is not valid Haskell syntax, man.
No, yeah, but to say
No, the integer is for this for all, right? This integer.
yeah, but the dollar would receive sometimes a type and sometimes a value. We don't have.
No, I'm overloading this stuff. Receives a type. And then you're passing an integer. Okay. And this is good enough. No, it's not good enough.
Not at all.
For all A to A to A.
And that doesn't make sense on the signature.
Oh yeah. No, actually it does. You can make it like this.
Ah, F sharp like. Oh wait.
And this is like this.
Oh, okay, yeah, sure. We are not doing the signature. We are doing the expression. Yeah.
Yeah. Okay. Okay. So now we can go through this with Magete. Magete, are you still there?
Mhm. Yeah.
Okay. So what is this, right? So the body is basically. Wait. This is incorrect
You can't even
mathematically.
read that, man. Not to
No,
hurt.
no, no. This this is a function that for all a and b, it grabs a function
Uh-huh.
from a to b and a and returns a b. Right. So
Hmm.
this is the type that we are expecting. Okay.
Okay. That
Um.
sounds okay.
So okay. So the
Please
body is
align the function.
applying. So the body, because this function, the actual value of this function is like this: f a
Yeah, I
fa.
get it.
Right. So the
Hmm.
body is this part. The ABST is the entire thing. And this is the type that we expect that this type checks. Okay, so
Hmm.
we do the for alls with E-type abstraction for A and B first. We call, then we create a function f. Then we say that it is a function that picks a type variable A that we just created with the for all to the type variable B that we also created with the for all. Then the body of this abstraction, right, is another abstraction because occurring. So we create an A. We say that it is a type variable A, right? Because in
Yes.
this case the names and the types are overloading their names, so it's kind of like this.
Hmm.
And I should actually change that to value. Uh, value function. Okay, function. No, too long. Fun. Okay.
That is also
Can you do
something.
me a favor?
Yeah.
Chew up. Go to the equal. Thank you.
uh, that is
That's all.
also something nice to test after that language.
Okay. Anyway,
Uh,
let me finish this explanation here because I'm almost finished. So then you pick the with the currying. You say that the body is the A, in this case x,
Hmm.
and you say that is the type with the type A that you created with the for all, and then you apply and then the body is the application, basically.
Hmm.
Okay, what is this should type is exactly like I was converting these A type abstractions to for alls along the way, right? Then type check this monstrosity to type prime, and it
Hmm.
works. And now I'm gonna do it again just to see the better names. Yay!
Oh man, please let's eliminate those warnings like they're pissing me.
uh, okay, we can do that. So, warning. So it's complaining the export item module is missing an export list. Is missing. Oh, it's because we are not doing best practices. Uh,
Oh, okay.
type check. Oh, you're still complaining. Oh, type checking test. Okay. Then it's gonna complain that I'm not using quick check anymore, which is correct. Then it's saying that we don't have the type signature for this guy. Done.
Oh man, much better.
hopefully, did we have
Really?
only those?
For in testing, yes, we have a bunch more with the
Oh,
REPL.
I see.
Anyway, go Nathan. You had a final test. How much
Yeah.
time? Oh, we have 2 hours and a half already. But we can go a little one more. Okay, go.
Quite the last one, but before receiving the function a to b, you receive the identity function. Then, on the body of the function, before you applying fun to value, you apply ID on both.
Yeah, get it.
Can I reuse? That would be awesome.
Oh yeah, the scope is the same, right?
I hope so. Because I actually don't know how these IT things work.
Oh, that is also.
Okay. Then we do the same, but the functionality is
Yeah.
identity.
Dude, it is still compiling. What the fuck?
Why are you
Hey,
surprised?
maybe that is one that is even like easier and maybe better to do.
Go ahead.
That's the ID. That's the one our languages don't support.
ID? What do you mean?
ID applied on ID. You cannot do that in OCaml, and I don't think so in Haskell also.
Really?
Mhm.
Oh, I see why. Oh man,
Uh,
I see why.
okay, I can type
You,
check it.
yeah, you can. No, I guess that's already enough. Why though?
No joy.
You can indeed.
Yeah,
Yeah.
I can. One. This warning is because I'm not using best practices, but I can convert this to best practices.
What is the type of ID there?
See?
For all, I think. Or is it?
Oh, that's nice.
Anyway, continue, go. What is the best way of testing?
Best way of testing.
Oh, we should also test exactly this guy, but applying the two things.
Wait. Let me see something.
So it's gonna be that applying identity and applying. I don't know. One. We can reuse stuff. That's cool. This one's gonna be. Oh no, but I kind of. Oh, that sucks. I kind of not can can do that like easily. But okay. Uh, so it's gonna be. Hmm. What's the best way of doing this? I think I'm gonna do like that. I'm gonna call this T prime prime. Then I'm gonna do E application of the IBS T, and the expression that I'm gonna send uh, is the identity. Okay, and this will also be another thing that I'm gonna pass the E literal and integer 1, so like that. And it is complaining still. What is the type of this expression? What is the type of this expression? So what are you complaining? Oh, it's because I forgot. E application. Oh, it's not in scope. It's not in scope, Mageta. Yeah, so it
Yeah, that
includes your own
sucks.
scope. Yeah.
Yeah, it makes sense because the do, I think, right?
Yeah, but we can make in this do.
Yeah.
So this one, these guys. I actually gonna put the type prime here because it doesn't make sense to be otherwise. Other place. Okay. Oops.
Look at this expression, man.
Crazy. T. Okay. Okay. Now we just have to make this thing. This should be integer. We don't need this then. The integer. What are the chances? No, no.
It was too good to be true.
It was too good to be true. Too good. Too freaking good. Am I making this thing correct? Because maybe I'm doing something wrong. I don't want that to happen. E-type application.
I'm still surprised with Haskell. I'm trying to figure out the ID thing, and I'm trying to find my own ID without type annotation, and it's still compiling.
Yeah, but maybe it doesn't work though. Remember the laziness.
No, I'm executing.
Yeah.
There is something weird about it, man.
Oh, I think I know why this is not doing. Because I think what I am... Yeah. So I think we need the E-type application, Magita. That's why it's not working.
Yeah.
We need to... Okay. We need to introduce those things. So it's gonna be... Wait. I am very confused right now. E-type application. What this guy expects? It expects an application, an expression, and a type. This is definitely an expression. So this should be a type now. I am confused. Oh, the parentheses are wrong. Crap. It's here. Yeah. So now we need something in here. So what is the type of this? This is a function.
Yes. Should be. Yeah, but you're not applying anything, so. Oh no, you are. Application on the abstraction, which is a. Oh man, there's so much to type check in your head that is
Oh
just.
yeah, it's hard. It's hard.
I
Nathan,
can't
are you
think.
there?
Wait, I'm
Nathan is
investigating
our
some
type
stuff.
checker.
He's still going with the ID stuff. Ah, my head hurts. It hurts.
Being a computer is hard, man.
Oh yeah, being a compiler is fucking complicated.
It, man. Haskell.
Ah, my head hurts, man. It
And it is
freaking
still
hurts.
compiling. But I'm gonna sleep and this thing will be processing here.
Ah, my head hurts. My
And I'll
head, my
probably
head.
Wait
wake
just
up
a
with.
second, man.
Wait just a
I
sec.
think I downloaded F star though. That's what matters.
Wait just a sec.
Okay, I think I made the thing binary now. But well, I investigate why later. So what is the problem?
I think I found it. We want to do this line here.
Oh, that's not possible, man.
Why?
Because, wow, you are doing an application with identity. But identity needs a type application, right?
Wait. Identity type. Wait, can you repeat what you said?
Yeah.
Go.
So identity needs to take a type. what you are doing is receiving identity and applying to a value, right? Or at least is what your
Oh,
signature
you're
intends to
correct.
do.
You're correct. Okay, so I want to apply, but I want to apply identity to this, but the identity
Yeah,
also
what I
expects something.
meant, yeah, what I meant was to receive the identity uh, alongside
E-type
the other things,
application,
right?
and then you put it in a t integer here. Correct? Is this correct? I'm going crazy? Yeah. So for instance, here, you see, I
Wait.
guess all of these can be just identity. Yeah. So this is kind of what we want. It's an E application, E-type application, identity to integer, exactly like that. And the result of this, the result of that, what I'm saying, this is not result, this is an expression, this is the type. So why is this type application not working? That's what I want to understand. Couldn't match expected type with actual type expression in the second, whatever the hell is that. E-type application, it expects an expression and a type. ABST is an expression, this is a type. What is the problem? Nathan.
Uh, wait.
I
What
think
is the
I'm going
problem?
crazy. Yeah.
So let me see what you wrote. Application. Like, man, it's so hard to read that. Like,
Oh
can you
yeah.
indent stuff?
No.
Like, well, you can.
Okay. Let's go through parts. So forget this other external application for now. Forget all of this. Okay. Just pay attention
Yeah,
to this. Okay.
yeah, you're
So
doing top the application of identity in integer that you return the integer to integer, and then you are doing
just 1 sec.
uh, application. Yeah, that's not a type.
Okay, go.
That's not a type. The second argument to type
Oh,
application.
this is.
Yeah, this is.
Oh, okay. So actually, it's like that. Okay, that makes.
You're sure that's what you want?
Uh, I'm sure that it is what I want. I'm not certain. What I want is written here. I want to be able to, instead of using a generic
Yeah, what
A2A, I want to use
you
a.
wrote there is impossible.
I don't understand why still.
Wow, because what is the type of identity?
A2A.
Uh, Not exactly.
For all A2A, I guess.
Yeah, so what do you want? What can you do with that? You can do a type application, right?
Yes.
Let me see. Can you do that? You receive the identity. Well, you can, but your abstraction will not be the same, right?
Yeah, no, it's
Because
gonna
in
be,
your
yeah, in the case of these specific examples, A is equal to B.
no. What I mean is, take a look on your abstraction, right?
Here.
It is doing an application side. If you take a look on the body,
Yes, it is.
but you are doing an application of a type abstraction in a value. You are applying a T for all in a value.
I think it's I'm throwing smoke out of my head, man.
Yes.
Uh, So the identity that you are passing is expecting a type. You are applying to a value.
The identity that I'm passing. The identity itself is expecting a type.
Yeah,
No, but you
because
can
it is
fix
a.
that.
Well, you can, but then the body is something else, right?
But then the body is something. Wait.
Folks are not getting anything.
Oh, I'm
So
getting. I'm getting. It's because
And then the
Nathan's right.
signature
Nathan's
cannot be
right.
this.
Yeah, Nathan's right. We cannot use this abstraction in combination with identity because this is already setting the body as an application, and identity is doing nothing. It's just throwing the same thing that is receiving, which is indeed correct. Holy balls. Wait. Yeah, so I can't reuse this. That sucks.
Yeah, and also the signature would be wrong.
Ooh, okay, but that's the end for me. I can't do anymore.
yeah, I'm starting my presentation F star right now.
Okay, I'm gonna finish the recording now.